Hi, we are Engineering Brothers, and once again we have got our another interesting class. And quite naturally, in our previous class, we have described about the concept of our stability and what is the exact definition of our stability over there. And we had used the ball or the position of the ball, and according to that surface. Or the placement of that ball, the concept of our stability would change in that case over there. And in this present case, we are trying to consider a simple conical structure over here. And according to the position of that same conical structure, the concept of our stability will change after that. In our previous class, we have described what is the exact definition of our stability, and there are some three occasions over there. The first, the system might be in the stable condition. In our second consideration, the system might be in a unstable consideration, and last but not the least, the system is in the not in the stable or not in the unstable condition. It has been placed at the marginally stable condition over there. So that is not the stable one, but that is not the unstable one. In between these two conditions, the placement of our marginally stable condition will be there. Now in this case, we are using another set of example over here. Now you can see that we have got a conical structure over here, and the picture actually define us that the conical structure is placed at the base of our consideration or at the base of our considered position. If you do see or understand that this is the base of our overall system, and the conical structure is placed at the base of our surface. In our second picture, you can see that the conical structure is placed at the tip of our surface. Okay, and at the last consideration for our conical structure, it has been placed at the horizontal surface of our conical structure. Now what is the exact difference in between these three consideration, or in between these three pictures over there in terms of stability? First of all, if you just do say or see that at the picture of our diagram A, it is been placed at the base of our overall surface. The conical structure is placed at the base of our overall surface. Now if you just do apply the much needed disturbance in any point of our conical structure, say in this point, or anywhere in between this conical structure, it is been getting disturbed by that oscillatory motion. But after some time, it will get back to its original equilibrium position over there, that is identical with our previous consideration over there. Now we can say that this system is quite naturally our stable one. How do I say that? As if you just do apply the disturbance on this given surface of this cone, quite naturally, as this is being placed at the base of our overall structure, if you just do apply the disturbance on this conical structure, it is been making the oscillatory motion of our given consideration, and after some time or after some duration, you can do understand that it is been regained its original equilibrium position over there. Now quite naturally, because of that considered part, as it is regaining its original equilibrium position over there, quite naturally we can see that this is the exact example of our stable system over there. Now get back towards our next picture, which is our picture B, and if you do see that the conical structure is placed at the tip of our overall, now here you can see that the surface will be present over here, and that is been placed at the tip of our overall conical structure. Now if you just do apply the much needed disturbance over there, it is completely disturbed by that disturbance, and it is been placed or it is been considered at this horizontal surface over there. Now if you just do apply the disturbance, it is been getting disturbed over there, and after that it is been look like this one. Now quite naturally, as this conical structure for this case, as it is not been considered as our stable. Why? Because it is not regaining its original equilibrium position or equilibrium point over there. After, if you have applied the disturbance on this given conical structure, it is been look like this one. If you just do apply the disturbance on any point of a conical structure, the structure itself is look like this one. It is been getting disturbed by this one over there, and this is our given surface over here. Quite naturally, we can say that in this case, that the picture itself indicating that this is going to be our unstable, or the example of our unstable system over here. And last but not the least, for our conical structure of for our picture C, it has been placed at the horizontal part of a surface. If you do see that this is the surface area, and as this is being placed at the horizontal point of our conical structure, if we just do apply any disturbance on any type of our disturbance on this given overall system, it is been considering, or it is actually going to gain a new equilibrium position after we have applied that disturbance, but it is still not regaining its original equilibrium position over there. It has been shifted in this direction or in this direction over here, and because of that new equilibrium position over there, we can say that this is going to be our marginally stable condition. So there are three different stability conditions for our overall system over there. Specifically for our control system, the first one will be our stable one, and the second one will be our unstable system. The third one will be our marginally stable over here. And we have used the same structure of our conical one, but if you just do replace the positioning of our conical structure, that make us the original difference for our stability consideration over there. I want to repeat this portion once again because this portion is very vital. If you just put the conical structure at the base of our concrete or base of our as if you do see that this is the reference point, or this is the surface area of our considered floor over there, and if you just placed the conical structure at the base of our overall system, if you just do apply the disturbance, after some oscillatory motion, the system do itself regain its original equilibrium position over there, and we can say that this is stable. Why do I consider this as a stable? Because if after applying the disturbance, it is regaining its original position over there. Okay, that actually do give us the consideration for our stability or stable system for our example for our conical structure. In our next step, as this has been placed at the tip of our overall conical structure, if you just do apply the disturbance, it is actually disturbed by that simple or small disturbance on this given system over there, and after disturbance it is been moved back, that is been laid down on the floor, and because of that consideration it is not regaining its original equilibrium position over there. Now we can conclude that the system is unstable over here. And last but not the least, we are having our marginally stable consideration, as we can see that the conical structure is placed on the horizontal surface, and if you just do apply the disturbance on that given conical structure, it is gaining a new equilibrium point after some time, but still it is not regaining its original over there, because we can't resemble our previous equilibrium points over there. Now there you can see that we have considered our three important stability consideration with the help of our given examples over here. And quite naturally, the first one will be our stable system, the second one will be our unstable one, and the third one will be our marginally stable consideration over here. And we have described the concept of our stable, unstable and marginally stable with the help of our simple example over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos and keep following our channel. Just wait for my next videos over there, because lot of interesting videos are upcoming for our stability concepts over there. And in our control system, the concepts of stability is very important over here. That is why I have used two different set of examples to give you the total picture for our overall consideration for our stability. Stay tuned with our classes. Do follow our videos. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.